In this video, we're going to take a look at section 1.3, which is on equations of two variables, which is really a pretty misleading title for this section, as you will see as we go through the material. The first topic we're going to take a look at are the distance formula and the midpoint formula. This is something that you can calculate. These are two things that you can calculate given 2 points on a Cartesian coordinate system. So this will be first on graphing in this course. Let me just refresh your memory real quick. The Cartesian coordinate system is a set of two axes that intersect at a right angle. We have the horizontal axis, which is often labeled the x-axis. We have a vertical axis, which is often labeled the y-axis. And to describe any particular location in this Cartesian coordinate system, all you have to do is specify where that location lines up on the x-axis and where it lines up on the y-axis. So for example, if we have 1 on the x-axis and 2 on the y-axis, if we line up with 1 on the x and 2 on the y, that gives us this particular location here. So a good way of describing that location is it's the point that lines up with 1 on the x-axis and 2 on the y-axis. And so we would describe that point as 1, 2. The x value is given first, the value that it lines up with on the x-axis, the y value is given second. Right. Now, if we are given a second point, we could ask the question, what is the distance between these 2 points? So let me just kind of pick 2 random points. I'm not going to actually put numbers on them, because I want to talk about these formulas, and then we'll do an example with actual numbers. But let's just say we have a point here. Don't worry about what the x and y coordinate is for that, and a point here. Given those 2 points, we could ask, what is the distance between those 2 points? And there's a formula for it. And if I wanted to be a lazy teacher, I could just say, here's the formula, plug in, or maybe it's not even being a lazy teacher. Maybe this is what the students even want, is don't give me this backstory, just tell me how to get the right answer, right? But I don't like to do things that way. And so I'm going to explain to you why the formula looks the way it does. And it's a pretty interesting, story. So given these 2 points, the distance between these 2 points would be the length of the line segment that connects those 2 points. So whatever this length is here. And I can remember in grade school, maybe not grade school, that's a little bit too early. Sometime, probably middle school, I feel like I was kind of on the younger side, where I was presented with this problem. And my thought was, you want me to find the distance of between these 2 points of that line segment? Give me a ruler. I'll measure it. And I was thinking you could just take the ruler, put it up to the chalkboard or the paper, or in this case, the screen, and just see what the distance is using a ruler. And actually, the funny thing is that would work if the graph was drawn precisely enough. So if you wanted to measure the distance in inches, as long as your x-axis was carefully measured where each mark indicated another inch. So this would have to be exactly 1 inch. This would have to be exactly 1 inch, etc., etc. Same thing on the y-axis. This would have to be exactly 1 inch, exactly 1 inch. Then I could take a ruler and I could measure how many inches this line was, and it would be precise between those 2 points. But there's some limitations to that. One being, what if the distance is like 3.8925? It's some kind of decimal, not a very precise, easy number. I don't know. I feel like I'm saying that wrong. So what if it was not a whole number answer, but something that had several decimal places to it? That would be more difficult to discern from a ruler. The other issue is just the setup cost. If I want to make sure I get the right distance using a ruler, I have to put in a lot of time and work, making sure I'm setting up the graph correctly, precisely marking the location of those points, and precisely using the ruler correctly. And so there's a lot of work that would go into it, and it probably still wouldn't be exactly accurate. So what we're wanting to do instead is to calculate the distance algebraically. Let's calculate what it is using the numbers that we're given. And then we don't have to worry so much about whether we've set it up perfectly, because the numbers are going to do the thing they're supposed to do anyways. And it turns out to find distances algebraically is difficult to do when the distance is in a diagonal direction. but it's super duper easy to do when the distances are either just completely horizontal or completely vertical. So what we can do with this situation, instead of trying to find the distance diagonally directly, we can first focus on the distances we can find more easily, which is the horizontal distance between these 2 points. So what's the gap horizontally between these 2 points? And then the gap vertically between these 2 points. How far spaced apart are they in the vertical direction? And those are pretty easy to calculate because all you have to do is look at the x-axis to see you're going from x equals this up to x equals this, and you can find that distance pretty easily by just subtracting. You just find the difference in those two numbers, and that tells you the gap between them, which will tell you that distance. Let's just call that distance A for right now. Same thing for the vertical distance. All you have to do is look at the difference in the y-coordinates between these 2 points, and that would tell you what that gap is, which would be the vertical distance. And what we're looking for is this distance here, which we could call C, which is the diagonal distance. And notice that when I draw all that in, what I've created is a right triangle. And so the relationship between these 3 sides is just the Pythagorean theorem. And so the big punchline here that I was trying to get at is that the distance formula is just the Pythagorean theorem. So students will look at that and think, oh, that's really complicated looking. How am I ever going to remember it? What does it mean? And I just say it's just Pythagorean theorem. It's a squared plus b squared equals c squared. Except that instead of a, we have x2 minus x1. What those represent are the 2 x coordinates of your 2 points. So if we think of this as point number 1 and point number 2, this point has ordered pair x1 comma y1. Let me try that again. X1 comma y1. This is our second point, so we could label this ordered pair as x2 comma y2. And to measure that horizontal distance between these 2 points, as I mentioned earlier, you just subtract those x coordinates. This would be x1, this would be x2, and so that distance is going to be x2 minus x1. All right. And so that's what we have here instead of a. Same story for b. Instead of b, we have the y2 minus y1. And instead of c, which is what you normally see in Pythagorean theorem, we're going to use d for distance, because that's the distance that we're trying to find. And so really, this is just a squared plus b squared equals c squared. But we've modified it to fit this situation. All right, so that's the distance formula. Now, that's the backstory behind it. I'm hoping because now you understand why the formula looks the way it does, that maybe it won't be so hard to remember. And you'll understand it better. You'll be able to use it better because you understand what it is. So when we see an example, I will just use the formula. I'll say, what's x1, what's y1? Let's plug that in and calculate it. And so we'll do an example in just a second. Now, the midpoint formula also has kind of a little backstory behind it. The midpoint formula, or the midpoint itself, is represented as x bar comma y bar. So that's how you read that. There's a bar above this. And the formula is this, and it's an ordered pair. So it's a weird formula. It's not the kind of formula that you're used to working with. It's structured as an ordered pair because we're trying to find a point. And the point we're trying to find is the point exactly halfway in between these two points, excuse me. All right, so I'm trying to find the point exactly halfway in between. So it's going to have an x coordinate and a y coordinate, which we represent with bars. The x coordinate for the midpoint is just going to be x1 plus x2 divided by 2. You're going to add the 2 x coordinates together and divide by 2. The y coordinate of the midpoint is y1 plus y2 divided by 2. So you take your 2 y coordinates from your 2 points, add those together, divide by 2. That gives you the y coordinate of your midpoint. All you're doing here is taking an average. When you take the average of 2 numbers, you always get the number exactly in the middle between those 2, which is where this midpoint's going to occur. The x coordinate for the midpoint should be exactly halfway in between the x coordinates of our 2 points. The y coordinate of the midpoint should be exactly halfway in between the y coordinate of our 2 points, the y coordinates of our 2 points. And so this point, we just want the middle of the x coordinates and the middle of the y coordinates. You find that middle by taking an average. So again, you don't have to memorize this as y1 plus y2 divided by 2. Just remember, you're taking the average of the y coordinates. And then you know how to do an average. If you have 2 numbers, you add them together, you divide by 2. That's how you do an average. And this is literally what the bar means. X bar means the average of the X values. So there's only two X values because there's only two X coordinates. You take the average of those two numbers by adding them together and dividing by 2. So that's how you do the midpoint. All right, so let's go ahead and actually do an example. So here's 2 points. We don't actually even need to graph these. We can just plug them into the formula. This is my first point. This is my second point. It doesn't really matter which one's which, but I'm just going to label them in the order that they're given to me. And this is an X coordinate and a Y coordinate. This is also an X coordinate and a Y coordinate. But because this is an X and a Y for my first point, I'm going to put 1s on those as subscripts. Try to put 1s. Because this is my second point, I'm going to put 2s on these. And so now, and what I always recommend is whenever you're using a formula that requires you to plug in X1s and Y1s and X2s and Y2s, is to label the points first and then plug them in the way they're labeled. That way you're not going to accidentally plug in the wrong number into the wrong spot, which can happen. All right, so for the distance formula, I guess I'll do that over here. Let me just rewrite it. Remember, it's a squared plus b squared equals c squared, essentially. We're going to have x2 minus x1 squared plus y2 minus y1 squared equals the distance squared. Instead of x2, we have negative 3. Right? So I just look at my label. x2 is negative 3 minus x1, that's negative 2. Now you got to be especially careful when you're plugging negative numbers into a formula where subtraction is already occurring. And so notice I use parentheses here. We have negative 3 minus in the formula. Negative 2 is getting plugged in for x1. I don't want those two to blend in together, so I'm using parentheses so I know there's a double negative there. All right, plus y2, which is negative 1, minus y1, which is 3. All right, so again, just looking at my labels over here. And then I just simplify. And so this will become a plus, right? So this will be negative 3 plus 2, which is going to be negative 1 squared. Plus, this will be negative 1 minus 3, which is going to be negative 4 squared. And so when you square those, even though the numbers came out negative, after you square them, they become positive, right? So negative 1 squared is 1. Negative 4 squared is 16. And so we're going to get 17 here. Now the distance is not 17. The distance squared is 17. So how do I find the distance from that? You have to take the square root of both sides. So I will take the square root of both sides of this equal sign. And the square root cancels out that power of 2, and so I get that the distance is just equal to the square root of 17. And you just want to leave it that way. You know, you might be tempted to plug it into your calculator, but at this point anyways, we don't really want the decimal expansion for that number. We're just going to leave it as a radical. And so even though that's maybe an unsatisfactory answer, right? Because, you know, if I told you the distance I ran this morning was square root of 17 miles, you may not immediately know exactly how far that is. It can, if you want to have an idea of what that number is, just think of the closest number that does work out nice with the square root. So 17 doesn't work out nice, but 16 does. Square root of 16 is 4. 17 is just above 16. So this number is going to be something like 4.1. It's going to be just above 4.1 something. But we're just going to leave it as a radical. All right, so that's how you do distance between 2 points. Let's also do the midpoint. We'll do that over here in the space I left. Oh gosh, okay, that really went sideways. Okay, let's do that. All right, so we'll do the midpoint here. We have x bar, y bar. That's the midpoint. And the formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Again, we're just averaging. Something to be aware of with this formula is that most of the time when you have x1s and x2s in the same formula, you're subtracting them. Case in point would be finding the slope, right? It's y2 minus y1. Distance formula, y2 minus y1. But midpoint formula, y2 plus y1 or y1 plus y2. It doesn't matter which way you put those. You're adding, right? So be careful. A lot of major mistake students will make is that they subtract these by accident. You want to add them together. So we have x1, which is negative 2, plus x2, which is negative 3. Divide that by 2. For the y-coordinates, we have y1, which is 3, plus y2, which is negative 1. I kind of stutter because I'm saying There's 2's and 1's and 3's on those. The numbers are kind of getting jumbled up in my mouth. All right. And so we have -2 plus -3. That's going to be -5 divided by 2. And you might not be happy with that result because you're like, oh, that's not a very nice answer, but it's going to be a fraction sometimes. And that's the case here. Now this one works out better, right? We get 2 plus -1. That's going to be 2 over 2. Excuse me, my writing's getting horrible. And so we're going to simplify that. And we end up getting -5 over 2, comma 1. And that would be the point exactly halfway in between those 2 points. And the distance between those 2 points is going to be roughly 4.1 something, but exactly square root of 17. Okay, let's move on to another kind of problem. So again, this title of this section really is misleading because it's called Equations of Two Variables. And it's not a lie. That is what we're about to look at. But it's not what you would expect to be looking at first. Normally, when you're going to study equations of two variables, you start with the easiest of that particular topic, which would be lines, linear equations. And we will get to those in the next section in 1.4, even though we're going to see a little bit of it in this section. But the main topic in section 1.3 is actually graphing circles and working with the equations of circles, which is also an equation of two variables, but not the easiest kind of equation to be working with. And for many students, this is a new topic, or at least one that they have not spent a lot of time with in the past, so they seem to have a little bit of trouble with it. A circle is the set of all points that are the same distance away from a given point. So that's a pretty easy definition. On a flat surface, you get the shape that you would expect of a circle, and I want to try to draw it, but I'm going to try to draw a circle, but just with my setup, I don't think I'm going to do a very good job. But this is kind of what a circle looks like. All right, so that's it, right? We have a point in the middle, which actually is not part of the circle, but it's what we're measuring the distance relative to. Right, so we have this point in the middle, and then every point on the circle is the same distance from that point in the middle. So whether I pick this point here or this point over here, the distances are going to be the same, right? This distance should be the same as this distance. So we have special names for these features of a circle. The middle of the circle, it's a special name, but it's still a pretty bland name. It's called the center. That's the official technical name for that point. So from a given point, that given point that we're talking about here, from a given point, see if I can circle that. It's called the center of the circle. The distance that all the points are from that center is called the radius of the circle, which you probably already knew. All right, so this has distance r, radius. This also has distance r. Any point you pick, the distance will be r. And so you can maybe understand why, there's a logical sense here. Why are we doing circles instead of lines? Because if we talk about distance and midpoint, that's relevant to circles, right? Because the definition of a circle is it's all the points that are a certain distance away from a particular point. And midpoint is also somewhat relevant because if you take a diameter of a circle, which means 2 points that are on this exact opposite sides of the circle, right? So let's say this point, I'm a little bit off the mark there. This point here, this is a diameter which goes all the way through the circle, through the middle. The center of the circle is the midpoint between those 2 points, right? So if you have points that are on exact opposite sides of one another, the center will be the midpoint of those 2 points. And so circle really is an application of distance and midpoint. That's why we're doing this first. All right, so here is the formula for the equation of a circle. It should look pretty familiar. It's essentially the distance formula that we just were working on, right? But it's been modified. So again, the distance formula is just a modified version of the Pythagorean theorem. The formula for the equation of a circle is just a modified version of the distance formula, which is just a modified version of the Pythagorean theorem. All right, where these letters come from. The center has a special label for it because it's a special point that's actually not on the circle itself. And I don't know what these letters mean, why they were chosen, but we call the center H, K. So we give it some, the x coordinate is h, the y coordinate is k. So there's still an x and a y value, but we have a special label for those x and y values to distinguish them from the points that are actually on the circle, right? So the center is at h comma k. That's the label we give that particular point. And then there's infinitely many points on the circle. There's infinitely many points that are this particular distance away, right? So the radius is the distance. One of the points is h comma k, that's the center. Take any other point on the circle, and because there's so many of them, and the x and the y coordinates of those points will vary, they're all the same distance away from the center, but there's an infinite number of them, and they vary. The values vary. So we will represent a random point on the circle with just the x and the y variable, right? So any point, whether it's this point here or this point here, x comma y represents some random point that's chosen on the circle. It doesn't matter which point you're picking. So if you take these labels and plug them into the distance formula, right? So remember the distance formula, I'm going to write it flipped around, right? It's going to be x2 minus x1 squared plus y2 minus y1 squared equals the distance squared. And you plug in these new labels into that formula, you get the equation of a circle, right? So we're going to think of the center as our first point. That's going to be x1, y1. We'll think of our variables x and y as our second point. That'll be our x2, y2. And as I already mentioned, r is going to be the distance. So the distance is going to be r. And so we see that substitution right here. And you should see the same substitutions everywhere, right? x2 minus x1. Well, x2 is just our variable x. And then x1 is h. It's the x coordinate of the center. y2 is just our variable y, and y1 is k. It's the y coordinate of our center. And if you plug all those labels into the distance formula, you come up with this equation for a circle, the formula for the equation of a circle. It's a mouthful. All right, and so that's where that formula comes from. So again, just giving you some backstory for why that formula has to look the way that it does. It's really just the distance formula with these labels relevant to the concept of a circle. Okay, so let's look at some examples of the kinds of problems that you will be dealing with. So I see that my recording real estate here doesn't quite capture the problem that I have on the screen. So I'm going to pause the recording for a moment and adjust it. So it might look a little bit weird when I resume, but I think that's the best way to handle it. So just give me a second. Okay, so hopefully that wasn't too jarring, having the screen kind of jump or the resolution change. I don't know how it's going to look in the recording, but so hopefully you should be able to see the entire problem now. Find the center and the radius of the circle. They're giving us the equation, and then graph the circle. So this will be one kind of problem regarding circles that you will have on the homework is here's the equation, find the center and the radius from the equation, and then use that information to graph. And this is going to be the easier version of circle problems. They're going to get more difficult after this. And so to find the center and the radius, you want to take the equation that you're given, which is x plus 5 squared plus y squared equals 25, and compare it to the formula that we just developed. The formula for the equation of a circle is x minus h squared plus y minus k squared equals r squared, and you just want to line things up. And when you line up the h and the k and the r, that's going to give you the center and the radius for the circle that you're dealing with. So remember, the center is at h comma k. So once we identify the value for h and the value for k, we put those two numbers together, and that will be the center of the circle. So there's a couple of issues with both of these, actually, that we need to kind of talk about. So take a moment. You don't have to pause the video because it should just take you a second to come up with an answer. But what do you suppose the value of h is in this equation? So what do you think it would be? Now, if you said you think h is 5, that's a really common answer that I would get in class, but it isn't quite correct. And here's how you know it's not correct. If you think h is equal to 5 in this equation, take that value for h, plug it into the formula, and check to make sure that it actually does match up to the equation. And you will find it doesn't. Right? If I take 5 and I plug that in for h, what do I get here? I get x minus 5 squared. Whereas my equation is x plus 5 squared. And so h is not 5. That does not, using that value for h does not make the formula align with the equation that we were given. We have to use negative 5 for h. And if I plug in negative 5 for h, I get x minus negative 5, which becomes x plus 5. Then it matches the equation I was given. So the first thing you're going to have to realize is that when you look at the equation you're given, the value for h and for k is going to be the opposite sign of what's actually there in the equation in order to get the formula to match up to the equation. So h in this case is negative 5. Really common mistake for students to put positive 5 there. Now k is a little bit unusual because it's not even there, it's missing. And so what is k going to equal? It must be 0. That's the only way that number would have disappeared, is if it was a 0. And so k is equal to 0. So there's my center. It's at negative 5 comma 0, which is right here. Right? Another mistake I'll see students make on the test is negative 5 comma 0, they mark it right here. So be careful about where you put that mark. This is on the x-axis, right? The x coordinate's negative 5, the y coordinate's 0. So that mark should go on the x-axis. Right? What about the radius? What is the radius here? It's not 25. It's a little more rare of a mistake, but occasionally I'll get students that will say, oh, the radius is just this number here. This number is the radius squared, right? The radius squared is 25, which means the radius must be equal to 5. You take the square root of that number to get the actual radius. So what I'm looking for, because this is what a circle is I want all the points that are 5 away from the point negative 5 comma 0. And as we mentioned earlier when we were doing the distance formula, diagonal distances are hard to do in algebra. What's easy to do are vertical and horizontal distances. And so the easiest way to graph this when you're graphing it by hand is to measure out the distance vertically and horizontally from the center. So go 5 up, 5 down, 5 to the left, 5 to the right. So you can find 4 points really easily that are 5 away from the center by going up, down, left, and right. And from those 4 points, we will just do the best we can to connect them in a circular fashion. All right. So starting from here, if I go 5 up, I get this point here. So this point must be on the circle because it's 5 away from my center. If I go 5 down, I get this point right here. Then I want to go 5 to the left. I'm already at negative 5. If I go 5 to the left, I'll end up at negative 10. And then 5 to the right, which actually gets me back to the origin. So I get these 4 points, which are all 5 away from the center. And those are the easiest ones to find. If you're trying to go diagonally 5, that's going to be really hard to estimate. So with these 4 points, I have a pretty good sense of where that circle is located and what it looks like. And I feel like I'm trying to stall here because I know I'm going to draw this so horribly. But you should try to draw this as a circular, pattern. So try to connect these 4 points in a circle. And that's what I'm going to try to do now. So see what happens. Oh God, that was like a horrible straight line. Okay, so I should do more like this. Okay, there we go. Maybe if I sing while I do it, it'll come out better. That's still pretty bad though, but oh gosh. Okay, here's what I'm going to do. I'm going to pause it. And I'm going to try probably 10 or 20 times before I get it right. And then I'll resume it so you can see the best attempt that I come up with. So just give me a second. All right. Actually, that was like my very next attempt. So maybe a little bit of performance anxiety on my part. It's still horrible, but it's probably the best I'm going to be able to do with, my setup that I have. I'm bad at drawing circles anyways, but with the setup I have, so, oh man, my hat looks kind of funny now. I'm looking at it. I look like a little bit of a goofball. So I'm using this Wacom pad, which is totally awesome. But as you can see, it's just like a blank surface. I don't actually see what I'm writing when I'm writing it on the paving line, which I've gotten pretty good at. I've made several videos using this piece of equipment, and I've gotten a lot better at writing with it, even though I know my handwriting looks pretty horrible. Like this looks kind of bad to me. But some things are still pretty difficult for me to do, and drawing circles is one of them. As I mentioned, even if I could actually see what I'm writing as I'm writing it, it would be hard for me to do like on a piece of paper. But anyways, I'm wasting time. Let's just go ahead and move on. Okay, determine the center and the radius of the circle and then sketch the graph in this case. So let's do the same thing. First, you want to put the equation in order. You want to, not in order, but you want to put it in the right form. So the form we want to see the equation in is like this. Right. This is the standard form for the equation of a circle. So whenever we're given an equation that's a circle, we always want to take the time to rearrange it so that it looks like this formula here. And so what's different about this equation is that the y variable is on the right-hand side. We really want it to be on the left-hand side. Okay, sorry, I paused the recording again. My daughter was singing in the bathroom. I don't know if you guys could hear it, but okay. So we want to make our equation fit the formula. That's what I was trying to say. The y is on the right-hand side. We want to get it to the left-hand side so that the x and the y terms are together. So it's minus here. So what we're going to do is we will add the y plus 2 squared back to the other side. All right, so a mistake students will make here is they'll say, okay, well, the adding part they're pretty good with, but then they're going to say, well, should it be y minus 2? Because that's a plus there, and we want to do the opposite sign, right? We're doing the opposite sign here. That's going to negate it. And then from this opposite sign, everything else needs to be exactly the same for them to cancel each other out. So if you switch that to a minus 2, well, then these two things aren't canceling each other out, and it's incorrect. So make sure you keep the term the same, but only switch the sign in front of it in order to move it back to the other side. And so what we end up with is the x minus 2, which is already there, plus the y plus 2 squared equals 27. So I think I just kind of misspoke there for a second. So that's x minus 2 squared plus y plus 2 squared equals 27. So that's what the equation becomes. And now we can go through the same process we went through on the last example to find the center and the radius. So I'm going to encourage you at this point to pause the video, determine the center and the radius based on the equation that we have, and then resume the video to see if you came up with the right result. All right, so hopefully you paused the video and you came up with an answer. What you should have come up with is the center is at positive 2, comma negative 2. So again, h, to find the value of h, you take the opposite sign of the number that actually occurs in the equation. So we have a minus 2 in the equation, which means we want h to be positive 2. And if you get confused about that, because sometimes students do, all you have to do is plug it into the formula and check to make sure it actually matches back up. So if I take h equals 2, and I plug it into my formula here, I'll get x minus 2. And so it matches what's in the equation. So that's what we want. For k, you should get negative 2, right? We have a plus 2 in the equation. We want the opposite sign when we get the value for k, for our center. And so the center is at 2, comma negative 2. Now, I'm sorry I did not prepare you for dealing with this radius. The radius squared is 27, so if you said the radius was 27, that's incorrect. The radius is not 27. The radius squared is 27. To find the radius, you have to take the square root of that number. So the radius is going to be the square root of 27. So if you got square root of 27, excellent, good job. If you plug that into your calculator, you realize, oh, it's a decimal number. And as I mentioned before with the distance formula, if your answer comes out as a decimal, you kind of just want to leave it in radical form. Don't write it as a decimal, at least if you're going to type it in. Like when Math Excel asks you, like here, it's asking us for the center, you're going to type in 2, comma negative 2 into that box. When it asks you for the radius, you don't want the decimal form of it. You want to type it in as a radical. But if you type in square root of 27, that's also not correct. So decimal will not be correct. Square root of 27 would not be correct because you can simplify this radical, keeping it in radical form, but simplifying it. And so this is one of these topics in college algebra that it's just assumed you know how to do. We saw in section 1.1 that we had to factor. We had some problems in that section where we had to factor some things, and we didn't teach you how to factor. We didn't have a lesson on factoring. If you're in college algebra, we assume you know how to factor, that you've done that before and that you remember how to do it. Radicals was another thing I think I might have mentioned in that video in section 1.1. So square root of 27, you're expected to know how to simplify it. Now, I didn't mention this earlier in the video because with square root of 17, there's no simplifying that one, but with 27, it can be simplified. And the way you simplify it is you split it up as 9 times 3. And we take the square root of each of those separately. The square root of 9 simplifies, right? Square root of 9 is going to be 3. The square root of 3 part doesn't simplify. So it's still going to be a radical, but it's a simplified radical. And that's what you should have as your radius. That's what you want to type into Math Excel. Now, graphing here becomes more challenging because the radius, I'm just looking at my head. It's like crooked. I don't know. I guess my head's lopsided or something. Okay, the radius is not a very nice number. So for typing into Math Excel, it needs to be 3 square root of 3. But for graphing, I kind of made this point earlier, right? If I tell you I ran 3 square root of 3 miles today, you're not really going to know exactly how far that is, right? It's not a number that you're familiar enough with to have an idea of the magnitude of it, right? And so for graphing, we kind of need to know the magnitude of that number, right? So here's the center. So there's the Cartesian coordinate system. The center is at 2, negative 2. So here's 2, negative 2. So the center is located right here. I like to mark it with an X because I don't want to put a dot because this point is not actually the circle. It's not on the circle. It's the center of the circle. So I like to mark it in a different way. And the circle itself is 3 square root of 3 away from this point. So I want all the points that are 3 square root of 3 away from this particular point here. So how far do I go? So we'll do what we did in the last problem. We want to go up, down, left, and right, this distance. But I don't really know what that distance is. So for the purposes of typing it into Math Excel, you need to keep it as a radical. But for the purposes of graphing, you actually want to write it as a decimal so you have an idea of how far that is. And I'm not exactly sure what it's going to be, but I'm going to estimate without actually checking, so hopefully I'm close. I do know the square root of 25 is 5, and this is just slightly more than that. So I'm thinking it's going to be somewhere like 5.2 something, maybe 5.3 possibly, because it kind of gets a big jump early and then kind of slows down as it gets to the next whole number. So it might be like 5.2 or 5.3. Either way, my drawing's not going to look much different whether it's 5.2 or 5.3. So if I tell you I ran 3 square root of 3 miles today, you would know it's a little more than 5 miles. And that's what we're going to do on our graph. We're going to go a little bit more than 5 in all these directions. So I want to go a little bit more than 5 up. So this is going to be, I'm starting at negative 2, so I'm going to go 1, 2, 3, 4, 5. So, whoops, I don't want to write 5 there. This is actually at 3, right? But that's 5 up from my center, and then just a hair more than that, right? Just a little bit past 3. So that's going 5.2 up, 5.2 down. I might not have left myself enough room. 1, 2, 3, 4, 5. So this will be at negative 7. Just a little bit further below that for 5.2 down. 5.2 to the left, I guess we'll do next. So this will be 1, 2, 3, 4, 5. So this is at negative 3. Just a little bit beyond negative 3. And then 5 to the right. 1, 2, 3, 4, 5. So this will be at 7, just a little bit past 7. All right. And so we get those 4 points. So again, you want to find the 4 points that are up, down, left, and right, because those are the easiest to measure out the distance for, and then connect those 4 points as a circle, which I'm almost tempted to just skip that exercise because I know it's going to look horrible when I draw it. Let's try this. Okay, that wasn't so bad. Wow. Okay, I might have to... Oh, I spoke too soon. Okay, well, that really wasn't too bad at all. Wow. Okay, just have to hold my breath, I guess. So, all right. And so there's your circle. Now, you might say, oh, how am I supposed to do this on Math Excel? You won't have to. You do, obviously, for this one, because notice that the graphic I have is from Math Excel. It's a blank graph. They expect you to graph it. But you don't actually have to even find 4 points. You mark the center first, and then plot 1 point, and it does the rest of it for you, which is kind of unfortunate. So you mark 1 point, it draws the rest of the circle. Just make sure the 1 point you mark is 5 away from the center to get the graph right. This one, however, it can't do 5.2. It doesn't do decimal distances. And so it'll be multiple choice. But you should practice doing it by hand, just the same. Okay, now that was one version of circle problems. They give you the equation, they ask you to graph it and find the center and the radius. This is another version where they give you a description of the circle and then they want you to find the equation. So this time we're not given the equation, we are looking for the equation. And this is the easiest version of that problem because they just give us everything we need. Here's the center, here's the radius. So to find the equation of the circle given this description, we will use this formula. And remember, the center is the h and the k, and the radius is the r. So they couldn't be nicer about this. They gave us all the numbers we need to plug into our formula to get the equation. There's really no calculations to do here. We're going to plug in 8 for h, we're going to plug in -2 for k, and we're going to plug in 1/5 for r. Kind of missed the mark on that arrow. Let's just do that. All right, and then we'll have our equation. So we're going to have x minus h, which is 8 squared, plus y minus k, which is -2. So again, be careful. Minus sign in the formula, negative number getting plugged in, you get the double negative. And r is 1/5. Now that was kind of a not nice thing for them to do, right? They made the radius a fraction, but we'll deal with it just fine here in just a second. So this doesn't change. X minus 8 squared plus y. We can simplify this double negative. It becomes positive. Notice, and here's a mistake that some students will make. Because in the other direction, like here, if there's a +2, we switch the sign and make it negative when we get the value for k. So students will think, well, when I go in this direction, if k is negative, I got to switch the sign and plug in +2. But you don't have to do that because the formula switches the sign for you. So notice that we have -2 up here as our coordinate for the center, but +2 in the formula. The formula took care of it. So you don't have to change the sign here. The formula changes it for you. So if k is -2, plug -2 into the formula will switch it to +2 as you simplify it. All right, and then for a fraction, it's not as bad as it looks. Whenever you apply an exponent to a fraction, you just apply it to the top and bottom. So we get 1 squared, which is going to be 1, over 5 squared, which is 25. And there is the equation of the circle with a center at 8, -2 and a radius of 1/5. Right, so that was pretty easy. Just plug the numbers in. This one is going to be more work, and not only that, more common of a problem. So the one we just did, not very common. It's too easy to do too many of those. This is the one that's a little bit more work. You'll see a few more of these kind of problems. They still give us the center, which is nice. All right, so we're 2/3 of the way there. What we don't have in this problem is the radius. Instead, they tell us that the circle passes through the point 3, -1. And so what we're missing that we were given in the last problem, but not this problem, is what the radius is equal to. So we're going to actually have to find it. We're going to have to calculate the radius. Now, there's a couple ways you can approach it. I'm going to tell you a method that I think is easier for finding the radius, but there is another more maybe obvious way you could go, but I think it's more work. And the obvious way that you could go is to remember that the radius is the distance between the center and a point on the circle, which is what you're given here, right? So this is a point on the circle, that's the center. The radius is just the distance between those two numbers. Or sorry, it's the distance between those 2 points. And so what Math Excel probably would tell you to do, what other teachers might tell you to do, is to say, well, go back to the distance formula. Because, as math teachers, we do like to make use of previous knowledge, right? So if we introduce the distance formula, we want to be able to show how it's useful later. And this is where you would do that. You would say the radius is going to be that distance between these 2 points. Use this formula, find the distance between these 2 points, there's your radius. But here's the way I like to approach it. I like to actually find the radius within the progress of the problem. We already have the center, which is h and k. Let's just go ahead and plug that into our formula, right? So here is the circle, right? This is the formula for the equation of a circle. Let's just go ahead and plug those values for h and k into this formula. So use what you already have, right? H is 2, so we're going to get x minus 2. Again, notice it's positive 2 here. The formula changes the sign for me, so I don't have to do it. It comes out as x minus 2 in the equation, right? So it's opposite sign like it's supposed to be. Plus y minus k, we're going to plug in 8, so I get y minus 8 squared there. I don't know the radius, so I'm just going to leave that as r. So what we can do is we can take this point that we're given, 3, negative 1, it's a point on the circle. That's what these variables are here to represent, right? X and Y represent points on the circle. Any point on the circle can be represented by that X and that Y. So we'll take the point that they provide us, plug that in for X and Y into our formula for the circle. Temporarily. So again, this is just a temporary measure. So I'm going to plug in 3 for X, and I'm going to plug in negative 1 for y. And I still don't know r, so I still copy that down. But now, by plugging that point in for x and y, it removes those as variables, because now they're just numbers. And the only letter I have left in this equation is r, which means I can now solve for r and find out what r is equal to. So I'm actually using the formula for the circle to help me find the radius instead of having to use a whole separate formula to find the radius, if that makes sense. I'm kind of doing it within the process of finding the equation of a circle. All right, and so 3 minus 2 is going to be 1, so we get 1 squared there. Negative 1 minus 8 will be negative 9, so we get negative 9 squared there. We simplify these, we get 1 plus 81 equals r squared. Now here's where I kind of lose some students with this process. You add those together, you get 82. Now, 82 is not the radius. That's the radius squared. Right? If I want the radius, just like we've talked about already, got to do the square root of both sides. Right? Which I'm actually not going to leave there, but you do the square root of both sides, and you get r is equal to the square root of 82. So if you really want to know what the radius is, it's the square root of 82. Right? Which may or may not be something you could simplify. But I don't really care to know the radius in this situation, right? The formula doesn't want just the radius. So if you go back to the formula where we're trying to put our equation together, what do we have here, right? We have h, we have k, we have r, but really we have r squared on the right-hand side. So what I really want to have on the right-hand side instead of so how do I want to say this? What I really want on the right-hand side is the radius squared. I don't really need to know what r is equal to. What I really need to know is what r squared is. And then I can replace r squared with the 82. So it's a little bit different. I'm not just plugging a number into a variable. I'm substituting two equivalent things, right? R squared is 82. They're equivalent. R squared is the same thing as the number 82 in this particular problem. So I'm replacing the r squared here with its equivalent value, which is 82. So you can stop at r squared is the point I'm trying to make. You don't have to take it this far. You can if you want to. It's just a couple of unnecessary extra steps. You can stop at r squared, replace the r squared in the formula with 82. And so my final answer would be x minus 2 squared plus y minus 8 squared equals 82. Now, if that bothers you, if you Because some students, I think they can kind of follow it, but they're just like, that doesn't feel right. It kind of bothers me to do it like that. Or maybe it is kind of hard to follow how that works. You can solve it for r, right? You get r is equal to the square root of 82. Then what would you do? You plug it back into your formula. So you plug it back in right here. You get x minus 2 squared plus y minus 8 squared equals the square root of 82 squared, right? Because you're plugging square root of 82 in for r. And then what's going to happen here is that power of 2 cancels out that square root, and you just get 82 anyways. So like I said, if you solve it for r, if that's what you feel like you need to do to feel like you understand the process, it's fine. It gets you the same answer either way. But it is a couple of extra steps. Taking the square root to find r, and then when you plug it in, having that square root cancel out with the power of 2. All right. So that's a really common kind of problem. Given the center and a point on the circle, find the equation of the circle. And this is how you would do that. The third kind of problem involving circles in this section is a problem where the equation is not put together in the way we need it to be. So let's look at an example before we talk about that process. So here, what we need for a circle is we need the formula to look like this. X minus h squared plus y minus k squared equals r squared. Once the equation has that form, we get all the good information we need to find the center and the radius and to graph it. If it's not in that form, that information is beyond our knowing. We can't just look at the equation and know it. So maybe I'm being a little bit too dramatic with what I just said. It's not beyond our knowing. We can figure it out, but it's going to take some work. So let me rephrase what I just said. If it's not in this form, you can't just get the information by looking at the equation. You're going to have to do some work. And the work is going to be to rewrite the equation so it looks like this, so that we can get that information. So really, you cannot find the center and the radius unless the equation is going to look like this formula looks. And this equation does not look like this formula looks, right? We have x squared minus 12x. So the way I kind of think of it is it's kind of spilled out, right? Instead of having it in a nice tidy package where it's factored and it's x minus h squared, it's been multiplied out and the x is kind of spilled out into the equation. And so we need to pick it back up. We need to sweep it back up into this nice package so that we can find the value for h and the value for k so that we can figure out what the center is, right? And to do that, I'm going to rewrite this equation. Y squared minus, same thing with y, same issue, right? It's not factored into this nice package, it's spilled out. So we cannot identify h and k by looking at this equation. We have to do some work to rewrite the equation to make it look like the formula that we're used to. And then once we have it in this form, then we can find h and k, which would tell us the center, right? And the radius also is not going to be 0. That doesn't even make sense, right? How can the radius be 0? And they kind of do that on purpose so that you can't just look at this and figure out the center and the radius, because if you tried, you would find that the radius is 0, which is silly. A circle cannot have a radius of 0. If the radius is 0, it's just a point. It's not a circle. All right, so how do I make this set of x terms look like this? All right, that's the question. How do I go from this to this? That's what this process is for. All right, whoops, I hit the wrong button. It was a great setup, and then I dropped the ball. Completing the square of that kind of expression. So the process we want to use is called completing the square. And this is a process of taking two terms and rewriting it so that it factors as a perfect square, which means it factors as one expression to the second power, which is exactly what we want here. We want to rewrite this as one factor to the second power. And so completing the square is what allows us to do that. This is the process. It's not a hard process. It's just a lot of little steps, which can be maybe a little bit hard to remember, but the steps themselves are fairly straightforward and simple. First, find b, which is this number here in front of the x term, the coefficient of the x term. What is that number in front of x? That's what you want to find first. Then divide it by 2, so you get b divided by 2, whatever b is divided by 2, and then square that result. This is the special magic missing number that you need to add to this expression to make it factor like this. So that process tells you the number that you need for it to factor in this special way. So you add it to that expression so that you will get it to factor the way it needs to factor. But if you add it to one side of the equation, you got to add the same thing to the other side, right? So whatever you're adding here to the x's, you have to also add to the right-hand side of the equation. Then you can factor this, and it will factor as x plus whatever this b divided by 2 was, will end up inside of that factor, and then to the second power. So that's how it will factor every time, because of the way you're constructing it, you know this is the way it will factor every time. Now, you may not need to memorize step 5 for every problem, but what can happen sometimes, because you're dividing by 2, is you might get a fraction. And if it's a fraction, that's hard to factor. Then you really need to use this formula here to figure out how it should look. If it ends up not being a fraction, you should be able to factor it without memorizing what the answer is supposed to look like. So let's look at this example. We have x minus 12x. Sorry, I said x. We have x squared minus 12x. Right? So in this case, b is negative 12. This is our value for b in this particular example. So let's do this over here. b is negative 12 for the x's. We're going to have to do the same process for the y's, but in that case, it'll be negative 16. Right? That's step 1. What is b? It's negative 12 for the x variable. Step 2 is to divide that by 2. So I'm going to take negative 12 divided by 2, which is negative 6. So works out pretty nice. Step 3 is to square that. And so we're going to take negative 6 squared, which gives me 36. That's the special number that we need here for this to factor in this special way. And so I will add a 36 to these x terms, which is why when I rewrote the equation, I left that little space so that I could add this special number in to those x variables. If I add it to the left-hand side, I have to add the same thing to the right-hand side. All right. Now this will factor as a perfect square, and I don't need to use that formula to help me figure out how it factors, because these numbers, you should know how this factors. What are two numbers that multiply to 36 but add to negative 12? You should find it's negative 6 and negative 6. So what should happen, if you've done this correctly, is that the two numbers you find should be the same. And that way you're getting the same factor twice. And if it's the same factor twice, you can write it as that factor squared, right? So x minus 6 times x minus 6 is really just x minus 6 squared. Right? Now it matches the formula for a circle, right? And now we can see h is equal to 6. So what I want you to do is the same thing for the y variable. So pause the video and then see if you can complete the square for the y variables. Right? And then resume the video to see if you came up with the right result. Right? So we want to make it look like this, y minus k squared. So in this case, b is negative 16. So you're going to have negative 16. Divide that by 2, you get negative 8. Square it, you get 64. Let me rewrite that too. Square it, we get 64. So that's the special number you need for the y variables to make it factor the right way. So if you add 64 to the left-hand side, you have to add 64 to the right-hand side. How is this going to factor? It factors as y minus 8 times y minus 8, which gives me y minus 8 squared. Since it's the same factor twice, I can write it as that factor to the second power. And then the right-hand side, when I add up all these numbers, I get 100. Right? So this is the first step. Maybe not the first step, but this is where you need to get in order to answer the question. Right? So you need to make, so it's the same equation. It's just now it looks different, and it looks like the formula that we've been using all along in this whole video. And now we can find the center and the radius. Now that the equation looks like this. So the center is going to be at h comma k. Okay, wow, it's getting really laggy for some reason. H comma k. In this case, h is 6, k is 8. So the center is at 6, 8. The radius squared is 100, so the radius is equal to 10. And now we can answer those questions. But before we can answer the questions, we have to make the equation look like the formula that we have. And to make it look like the formula that we have to go through this process of completing the square for the x and the y variables. And this is by far one of the most challenging problems in not only section 1.3, but in all of chapter 1. So don't feel too bad if it was difficult, if you found it difficult. Okay, so we're almost done. Now this section is crazy long. In fact, every section of chapter 1 is fairly lengthy. So I apologize for the length of this video, but unfortunately I think that's just going to be the more common outcome as we go through chapter 1, is the videos are going to be an hour plus. There's just a lot of things to talk about because it's reviewing a lot of different topics. Not that circles were so much of a review, but just a lot of different topics in every section. And I want to make sure I'm thorough. So the last topic is actually on graphing lines. It's just really, I feel like it's out of place. And in class, I will often say, okay, that's 1.3. Let's just stop after we do circles. And then I include this with my material for section 1.4, which is already a pretty long section, but I just put it with that material because that's really where it belongs. 1.4 is on linear equations, and that's what we're about to look at here. But for the videos, I think I should organize it according to what you're going to see in the homework and what you're going to see in the book. So finding the x and y intercepts of any equation. This isn't actually just applicable to linear equations. This is true for any kind of equation. If you ever want to find the y-intercept. Now the y-intercept is where the graph, I should have the definition somewhere here, where the graph crosses the y-axis. Right. That's the y-intercept. To find where the graph crosses the y-axis, you set x equal to 0 and you solve for y. Again, I like to give a backstory for that. So why does that process work? So let's say the graph crosses here. Let's say you have a line like this. Okay, and it didn't cross there. Let's do this. All right, and so the graph crosses the y-axis here. This is the y-intercept for this graph. What do you know about that point? Now, what a lot of students will say is it's positive. Well, yes, based on the way I've drawn this, we do know that the y-coordinate is positive because it's above the origin. And so we know it's positive, but do you know what the y-coordinate is? No. Could be 1, could be 2, could be 3. I didn't give enough detail for you to know that. But even with that lack of detail, what else do you know about this point? You know that the x-coordinate would have to be 0. For that point to be on the y-axis, the x-coordinate is 0, and the y-coordinate is going to be some positive number, but we don't know what it is. But you do know the x-coordinate is 0. And so we know the x-coordinate has to be 0, which is why to find the y-intercept, you set the x-coordinate or the x variable equal to 0, because the x-coordinate will be 0 for that particular point. And so we set x equal to 0 in the equation, and then we solve for y to find that y-coordinate. Same reasoning for the x-intercepts. This is where the graph crosses the x-axis. Crosses the x-axis. And so if you think about this graph here, where is it crossing the x-axis? It crosses right here. What do we know about that point? Well, we know it's the x-coordinate's negative because it's over here to the left. But what do we know even more specifically than that? We know that the y-coordinate has to be 0 for the point to be on the x-axis. So we know the y-coordinate is 0 for x-intercepts. Right? So this is the x-intercept here. The y-coordinate has to be 0 for that particular point. Right? And so to find the x-intercept, you'll set the y variable equal to 0 because for the x-intercept, the y-coordinate is 0. And so we set y equal to 0 in that equation, and then we solve for x to find what the x-coordinate would have to be for that particular point. This process will never change ever throughout this course or any other course you might take. If you ever, no matter how crazy the equations get, if you ever want to find the y-intercept, it's the same 2 steps. You set x equal to 0 and then you solve for y. That always tells you the y-intercept. And no matter how crazy the equations get, if you ever want to find the x-intercept, you set y equal to 0 and you solve for x. So this is set in stone. It will always be like this for every equation of 2 variables that we ever deal with. Right, now, we could go back and do this for circles, but it doesn't always work out so nice for circles. So that's why the textbook switches to linear equations. Even though we have not officially defined or introduced those, we don't do that until section 1.4. But this is a linear equation, which means the graph is going to be a line. And to graph a line, we need 2 points. And 2 points that you can find are the x and the y-intercept. And so that's what the directions exhort you to do. So be sure to find and show the x and y intercepts. So I think even though to graph a line, any 2 points would work as long as they're on the line that you're looking for. If you use 2 random points from this equation, even if they're correct points, the Math Excel will not count it correct unless they're the intercepts. So I think you have to use the intercepts for Math Excel to count this correctly for this particular problem. And so let's find, we'll do the x-intercept first. I don't know why I picked that one first. And so our equation is x equals 3y minus 90. The first step to find the x-intercept, if you remember, is to set y equal to 0, right? So we'll have x equals 3 times 0 minus 90. Because that's 0, that just goes away, and we get that x is equal to negative 90, right? So I kind of skip past it, but step 2 is to now solve for x. We find x is equal to negative 90. The y-intercept, let's find that. So let's rewrite the equation. To find the y-intercept, the first step is to set x equal to 0. And then the second step is to solve that for y. Now this time we're going to have to do a little bit of work. So to solve this for y, we'll add 90 to the other side. We get 90 is equal to 3y. You divide by 3 on both sides, and you get that y is equal to 30. So let me rewrite that y. Okay. So you get y is equal to 30. Okay. Now I kind of want to make a point with this. I know this video is already over an hour, but I want to make sure I'm still thorough in how I cover this material to help you avoid making mistakes. So what some students will do in this situation, it's very tempting to do. They say, oh, here's an x, here's a y. Well, they obviously belong together, right? X's and y's pair together. And so sometimes on the test, sometimes in the homework, if they ask for this information, I will see students that pair this x value with this y value. And so I will see this on the test. And if you do this on the test, I will, even if you do everything else right and you graph it right, I'm going to take off a point for this. I'm really unhappy with how I'm drawing this here. Okay. Oh, gosh, way off the mark. I will take off a point because these don't pair together. This is incorrect. The negative 90 for this x goes with y equals 0, right? We set y equal to 0 to get x equals negative 90. And so this is what should pair together. So really the proper way of writing an x-intercept is not to say the x-intercept's negative 90. It's very common for people to describe it that way. It's even kind of acceptable for people to describe it that way. But the proper, technically correct way of writing an x-intercept is as an ordered pair, because the x-intercept is a point. So we should write it as an ordered pair. And it should be negative 90 comma 0. That is the ordered pair for the x-intercept. For the y-intercept, it is the x-coordinate is 0 and the y-coordinate was 30, right? And so the proper way of writing this point is 0 comma 30. Oh, I'm just really unhappy with how I'm writing a lot of these numbers. 30. Okay, it still looks horrible, but I'll leave it. Right, and so the y-intercept, technically, we could say let me back up. I'm saying two different things at the same time. We could say the y-intercept is 30, and that's really sort of acceptable to do, but not technically correct. The y-intercept is a point. We should describe it as an ordered pair. And the things that we pair together are 0 with 30, right? Because we set x equal to 0 to get y equals 30. Those are the two numbers that actually pair together. And so it becomes 0 comma 30. And if Math Excel were to ask you, it doesn't, but if it did ask you to type in the x and y intercept, you should type them in this way as ordered pairs. So now we can graph these. We have negative 90 comma 0. That's this point here. It's a really big number. And 0 comma 30, which is this point here. And then to graph it, because it's a linear equation, the graph is a line, we just draw a straight line connecting these 2 points, and that will be our graph. All right, so let me go ahead and do that real quick. So there is a straight line connecting those 2 points, and it really extends back to the left as well, even though there's not a lot of room there. The graph goes forever to the left and forever to the right. And so that's what the graph looks like. Okay. One more topic. I know it was already a bunch to go over, a lot of complicated things with circles, but for whatever reason, they want to squeeze this one into section 1.3 also, which is special types of lines. The special lines that I'm referring to are vertical lines and horizontal lines. A vertical line is a line that looks like, oh, that was not vertical at all. Let's try that again. Let's bring it back this way. Okay, so this is a vertical line. The equation for such a line has to have this form. Y equals a number, which I'm just using k as a representation of that number. It's not the same k that we talked about with the center of our circles. It's just a number. So if you have y equals a number, that graph will be a horizontal. Sorry, I'm saying the wrong thing. If you have y equals a number, that graph will be a vertical line. Right. If you have x equals some number, so again, I'm using h to represent some random number. It's not the same h as what we were dealing with the center of a circle. Then the graph will be a horizontal line, which means the graph will look like this. Right. So notice what's special about these equations is that x is missing from the equation of a vertical line, and y is missing from the equation of a horizontal line. Okay, so let's do a couple of quick examples of this, and we'll be done. So this is actually my last example. So x equals 6. That will be a vertical line. The y variable is missing, and so when we graph this, it will graph as a vertical line. Where do we graph this vertical line? It passes through 6 on the x-axis. So there's a couple mistakes I'll see students make with this situation. On the test, I'll have some students that just mark a point here. And I don't know why I did such a bad job of marking that point. So they'll bubble in a point. I'm trying to make it easy to see, but without being too crazy. And so that's all I'll see on the test, is there'll be a point here marked at 6. That is not correct. Even though it's just x equals 6, a y variable is implied by the situation, by the circumstances. And really what this equation is saying is it doesn't care what the y variable is. It can be any number you want. What it cares about is that the x variable is always equal to 6. So in terms of the ordered pairs that we're graphing, it doesn't care what the y coordinate is equal to, as long as the x coordinate is always equal to 6. And so the y coordinate can be 0. That's fine. You can set y equal to 0, but the x coordinate still needs to be 6. The y coordinate can be 1. That's fine, but the x coordinate has to equal 6. So this equation is saying that the only ordered pairs that are valid are ordered pairs where the x coordinate is 6, but the y coordinate can be any number. It can be 0, 1, 2, 3, whatever, right? The y coordinate can be 2, but the x coordinate has to still be 6, right? That's what this equation requires. 3. So any of these points satisfy this equation. As long as the x coordinate is 6, it will satisfy this equation. The y coordinate can vary and equal any number that we want it to equal. So if you're only marking this point as your graph, you're not acknowledging that the y coordinate can be other numbers as well. This point is 6, 0. So you're setting the y coordinate equal to 0, which is one possible way of satisfying this equation, but there's all these other ways as well. Now, so if that's all you do on the test, it's incorrect. What a lot of students remember is it's the vertical line that passes through 6 on the x-axis. So it's going to look like this. And on paper, that's easy enough to do. So you know that this equation is a vertical line. You know it should pass through 6 on the x-axis. And so you draw this vertical line going through 6 on the x-axis. And that's fine. But on Math Excel, you have to plot 2 points. If you want Math Excel to draw a line for you, you have to give it 2 points through which it draws the line. And so students will get stuck because they'll mark this point. Everybody goes to this point for some reason. And they're like, well, I wanted to draw a vertical line, but it's not doing it. I'm marking this point, but it's not drawing a vertical line. You need to pick a second point where the x coordinate is also a 6, and then it will draw the line for you. So mark another point. It doesn't matter where, as long as the x coordinate is still 6. So somewhere up or down, from the x-axis. So for example, this point right here would work, right? And so that's 6, 2. And when you mark that second point, then MathExcel will draw the line that you want it to draw. Just real quick for horizontal lines, let's say we had the equation y equals 2. Again, it's the same idea, except flipped around. The x-coordinate can be any number that you want, but the y-coordinate has to always equal 2. And so the y-coordinate's 2 no matter what. So we can have x equals 0, but the y-coordinate has to be 2. We can have x equals 1, but the y-coordinate has to be 2. So you get the idea. And if I want MathExcel to draw this line for me, I can't just mark the point 0, 2. It needs more information. It needs a second point in order to know what line you want it to draw. And so any other point would do as long as the y-coordinate's equal to 2. And so we have 3, 2, for example. That gives me a second point. And then with that second point, MathExcel would know to draw this line here. Okay, that was a little bit off the mark. I hit the wrong button. Okay. I'm just going to leave it because I can't erase it now that when you go back to a previous page and you come back, everything's locked in. I can't undo what I just did. And this is just going to be too hard to erase. And I'm also tired of talking. I'm ready to be done with this video. So I'm just going to leave it, but you get the idea. And then it would continue. Oh gosh, I can't leave it like that. The straight line would continue, to the right like that. Anyways, so that's how you get MathExcel to draw these horizontal and vertical lines. You have to plot 2 points. Just make sure for vertical lines, the x-coordinate's the same for both of the points that you pick. And for horizontal lines, the y-coordinate stays the same. And it should draw the line that you want it to draw. Okay, so that concludes the video on section 1.3. Sorry if it got a little bit weird at the end there. I feel like sometimes if I haven't eaten for a while, my blood sugar kind of drops and I get a little bit like loopy or lightheaded. And I feel like that kind of happened at the end of this video. Hopefully it's still coherent and correct and makes sense and you understand what's going on. So, but if not, if I'm your teacher, please contact me, email me if you have any questions about any of these problems or any of the problems on your homework. And I will see you in the next video for section 1.4.